what are the reasons, or why have you kept on going? Why haven't you given up?
I think, well, because we're so close now, and just like, I think our team is so like in line with what we want to achieve. Like we're all focused on, bringing good devices to the patients, and like what else what else do we really need to focus on? So I've always been interested in medical devices and like biology related subjects, just because it's, so interesting, and there's a lot of things we don't really know yet. So my background is actually mechanical engineering, but then when I was doing my master's and PhD, I focused more on biomedical research. And then when I came to Hong Kong, I was actually finishing my PhD thesis, and I was kind of looking around for opportunities in Hong Kong, and it's a little bit limited in the medical device field in Hong Kong, but I just happened to meet Sloan, our co-founder and CEO, through the MIT Alumni Network, and he was doing his PhD at the University of Hong Kong, and he had teamed up with some trauma surgeons in the orthopedics department, and they already knew that they wanted to work on medical devices, develop new implant technology, and both focus on the clinical and the research needs. So I joined the team first through a government grant. So we started to kind of work together in that way, building up our relationship and developing some of our first implant devices. And so it kind of was just luck that I found that team, and we had a good structure to kind of build up working together before spinning out of the university. We are focused on orthopedic implants, so bone implants, and mainly when for elderly patients, because as you get older, we all tend to our bones become weaker and more fragile, and just from a simple fall, we can easily break our wrist, our shoulder, our hip, and a lot of the implants don't work very well, especially for these elderly patients. Of course, our implants work for younger active patients, but we focus on this patient segment because they're the largest patient segment and have the most need. So on our team, we have, as I said, we're based out of, we started at the University of Hong Kong and Queen Mary Hospital here in Hong Kong. So our co-founders have trauma surgeons and engineers, as well as people with industry experience from some of the larger orthopedic companies. So we have a good mix of the clinical side, engineering side, and business side. So that's been one of the lucky things, is to have this diverse team that work well together, and that's been working really well for us. So as I said, we're focused on orthopedic implants, which is like this metal heart. It's actually very mechanical. So there's like plates and screws and nails, which are used in today's implants to hold these broken bone fragments together. But when you think about it, when you look at healthy bone, of course, it's still very dense and strong. So these metal rigid implants can work really well for those patients. But as we get older and our bone becomes more porous and weak and fragile, we need some better implant technology to reduce what we call like implant failure. So over time, or maybe as the patient starts to recover and bears more weight on the bone, the implant can actually move through the bone and even break out of the bone, which is quite painful and dangerous for these elderly patients. So we're trying to reduce these implant failure rates. And we're focused on trauma, so like shoulder, hip, and wrist fractures are our main focus right now. So one of the first things that we developed out of Hong Kong U is actually what we call our soft tip technology. So when we want to hold these broken bone fragments together, of course we need to compress the fragments so that they have enough time to heal and fuse back together. But while this healing occurs, we still need to be able to still need the implant to be able to bear some of the load, so it still needs some strength. So that's why we still have our metal components, but we also want to have reduce the stress at the interface between the bone and the metal implant. So one of our technologies is we use a biocompatible polymer at this interface between the hard metal rigid implant and the fragile bone. So it kind of bears some of the load every time the patient takes a step or moves their arm around. So it is reducing the chance of the implant to migrate through the bone and reduce the failure rate of the implants that we see today. And we're also working on a newer technology which can complement this. So sometimes when the bone, when you have the bone fracture, you have a lot of small parts. So it's like a multi-fragment fracture, and holding these little fragments together with screws and nails can be quite bulky and not very effective because they're so small, and it's hard to compress the fragments together. So we're also developing a technology to be able to create a what we call a tensegrity web of sutures to hold the more the more fragile and smaller fragments of bone together as well during the healing stage. And we're working on a new shoulder implant right now. So one of the last things I'll talk about is we've also developed a what we call the bone simulation software. So this also came out of our time at the University of Hong Kong. And basically right now, like if you wanted to say you are developing new implants, and rather than like going through the physical process of design and prototyping and doing some experiments in the lab, that whole like process, if you need to iterate, it can take quite a long time. So what we wanted to do is to be able to simulate more realistically like how implants behave in bone. And right now, there wasn't a good way to really model bone in terms of like the physical like cracking and crushing of the bone. It's a little bit technical, but before it was more like a mesh-based modeling. So you could only really see like the very beginning stages of an implant moving through the bone. But we want to see the whole process of the implant moving through the bone. How does it compact the bone? Like how much force does it take to move the implant all the way through the bone? So we can like simulate how different designs work before we actually go through the whole like physical prototyping and testing, so we can more quickly eliminate like bad designs basically. And this actually came out through the whole like coronavirus type of situation, because we had to do more working from home and not as much time in the lab. So it gave us more time to develop this simulation software to help us be more productive when we can't really be in the lab. And we've actually gotten some interest from some companies in this since it's quite new and different. So we'll see where that goes. Like the physical implant, some of the challenges as well. It is a medical device, so you have to go through the regulatory process, and some of the like testing that you need to do is a little bit different. So there's like the testing where you need to show that it works, that it's doing what you want it to do, and then there's the regulatory side, which is like more does the polymer break down, like does the polymer fatigue. So you have to kind of channel both directions. Like you want a really cool device that can do something really amazing, but then you have to think about the regulatory side in terms of like, what is FDA going to be concerned about? What kind of tests do you need? And these tests always, take longer and are more expensive than you anticipate. So we're close now with our first device in terms of finishing all the testing and submitting our regulatory submission. But it always, takes longer and takes more money than you think to get your first device to market. We work with distributors. So we've already kind of set up a relationship with the US and EU distributor. So their core focus is actually like helping companies like us, like smaller companies or startups get new products to the market. So they already have their own, network of hospitals and doctors that they work with. So the first step that we've kind of gone through is getting feedback from, their clinical network, testing out like how interested are they in this type of device, and then going through the actual hospital purchasing process is something that they're experts in. So that's something we haven't gone through yet, but they have a lot of experience. So hopefully they can help us through that.
What about the healthcare industry piece? Like how do you roll out a new product into the industry, into clinics, into hospitals, into the hands of doctors? What are some of the learnings from that process?
Yeah, so you kind of you have to balance, surgeons like to have new toys, want to try new things, but then also they like things that are familiar. So in terms of adoption, maybe some cool new features will get them interested, but then actually adopting it into the hospital in regular clinical use, you have to think about that as well, because they have budgets and they need to balance both safety of the device with good clinical evidence versus something that the surgeon wants to try, something new. So, and every surgeon has their opinion about what's the best, what works the best, what type of device is the best. So even though we try to ask a range of doctors on what type of device should we focus on, or we get different opinions. So it's just about understanding the market, and especially it differs by region. So Europe versus US, the use of some devices are quite different in terms of Europe sometimes uses a more conventional device, which is have 30 years of history, and the US is maybe using a newer version of that device. So it's just about understanding the market and where do you want to go to first, and building up a good relationship with the hospitals and doctors to get them to adopt your device.
I couldn't agree with you more. I've spoken to lots of doctors, and they're always interested in new technology, but when it comes to applying it, there are so many hoops to jump through in order for a hospital or a clinic to actually adopt a new way of doing what they've been doing. What about the software, the bone simulation software? How's that coming along, and where do you see that going?
Yeah, so in the past few months, we actually made a lot of progress in terms of making it more usable for practical applications. And because before it was kind of, it's still in development in terms of being able to use it for different applications. So we need to, depending on the clinical application, the setup of the software the experiment in the software is a little bit different. So we've been trying to streamline that process so that whether we want to use it for like a shoulder implant or a hip implant or a spine implant, we have like a streamlined process where we can set up the experiment and be able to easily run it. So we've had an intern working on it for the past few months, helping us to develop that process so that even if, like, say we wanted to license that software to a company, they could run it for their own implants. And we've also been looking into maybe providing that service for some of the larger companies or starting a collaboration project. So we've been reaching out to some of the large orthopedic companies and saying, hey, we have this cool new software. It can be applied for your type of implants, and it can help with your whole design process. And let's maybe do like a little starter project to see if you'd be interested in using it more, or even possibly like acquiring the software. So we've been exploring our options with that.
Or share a few tips, like looking back, as now, a founder of a hardware company or health tech company. What are some of the learnings that you would share with yourself looking in the past or with others in terms of the journey? What should they know?
I guess, well, when you look back, you kind of think, sometimes you think like, what did I spend all our time working on, because we're still getting our first device to market. And sometimes you just get caught up in you want to make it perfect, and you want to do all the tests. You want to make sure that of course it has to be safe, and the performance has to be have some advantages, but making the perfect device and going through multiple design iterations, you can always continue on with that. So I think we have some non-engineers on our team who kind of help to push us along to get us out of that cycle. So I think, just focusing on the bigger picture sometimes, stepping back and then, what do you really want to, where do you want to go? What do you really want to bring to the market? And, this isn't the only device that we're going to make. So I think, just kind of looking at the bigger picture and making sure that we're, on the right track and keep moving forward.
Already have a software platform. You have the soft bone implant. You're working on the shoulder implant. 3 to 5 years from now, where do you see the big picture of lifespans? What would you like to see for this company? I think because our founders are all, scientists and engineers, we want to see our devices out on the market and being used. So whether it's through our own company or from, being licensed or adopted, acquired by another orthopedics company, I think we just enjoy working together and creating new devices. So the surgeons, they always have new ideas from their practice in the clinic. So we're really good at taking it from, what's the clinical problem to
what solution can we come up with. So we just want to keep working together and creating new devices, and then either selling them through our company or spinning them off to another company. But yeah.
Is all the best, and look forward to hearing from you and Sloan when the product rolls out later this year. Thank you very much.
Yeah, we'll keep you updated.